Hi, my name is Piotr Gejgalis and I work as a front-end developer for CodiLime. Welcome to the next episode of series MobX in React. Today I want to talk about scalable state management with MobX. Before I start, I need to warn you, this presentation may contain opinionated content and unpopular opinions based on my professional experience, and it's suitable for classic single-page applications and have not been validated with server-side rendering. I'm gonna start with presenting you types of the states in the single-page application. Then I will focus which states are the areas for MobX. Then I will show you how to share stores across the application components. And at the end, I will code example with everything I presented you before. So what are the types of states in single-page applications? We can divide them by source. So the first one is the client state in application memory. This is an ephemeral state which is lost after the user refreshes the page. We keep their usually state like modal opened or selected IDs, so this is not connected with anything outside the browser. The second one, the server state, is used with external data like responses from HTTP requests. The location state is often overlooked, but it contains very important data like path name, params, search or hash. We have also the storage state, which sits inside the browsers. One is local storage, the second session storage. It can be also IndexedDB in newer browsers. We can divide types of the states also by usage in React. The first one is the local. If you use useRef, useState or useReducer, it's probably for the local state, not always, because sometimes can be lifted state. So those states created using those tools may be lifted and passed down to the children components by props drilling or React context. We have also the global state, and the obvious candidate for that is a Redux library. So this state is shared across all the components in our application. We have the derived state, and Redux selectors are examples of that, or any inline code inside body of components, or cached by use memo helper. We have also state which lives between parent and child components, and it's usually implemented by React props. And the last state is the form state, which lives inside the single form instance, and I would suggest here to use dedicated libraries for that, like Formic or React Hook Form. So now where MobX fits, for sure it's the best candidate for client state. We can wrap also server requests and cache the responses by MobX. The same with location. We can synchronize MobX state with a browser location state, and the same for the storage. And by usage in React, we can use MobX in local, lifted, global. Derived is of course implemented by computed properties in MobX, and I don't think it's useful for prop state. And as I said before, for the forms I would use just default values from MobX, and I would handle the submission. I need to focus on local, lifted and global state to figure out how to implement it using the MobX. We have application with app component at the top, users and the dashboard components as a children components, and each one has its own children. So when we create and use the state which is inside users list component and it's not passed down to its children, then we have a local state. The lifted state is when we create the state in a users level component and we pass down to user model and users list components to be consumers of this state. And the global state is when we create this state at the top of the application and all the components in our application are able to consume it. And what MobX documentation suggests how to construct each other. The local state can be constructed by use state and observable helper from MobX. So we have a timer which is a store with one action and one data. The other example from documentation is by using use local observable helper from MobX React Lite library. We have directly access to the timer store and later the code looks the same. The lifted state is suggested to be implemented by one class which is our store. The class uses make auto observable helper to make actions and observable fields, and later in the parent view component we need to create the context, and first we need to instantiate only once this timer store using use state, and when we have ready instance we can pass it as a value of timer context provider. Then we can nest the child views like timer view, and timer view is now a consumer by using use context and it gets the timer which were provided above. And by having observer wrapper we can react on changes on this store changes. The last one, the global state, is suggested to be implemented with special root store Inside the store, in the constructor, we need to create all children stores and remembers them on the properties, and we should also pass reference to the root store to the children. So every child store has in constructor access to the root store, and when some action or computed function needs another store, then it can be accessed by this dot root store dot anything else store dot anything data. So in that case the root store only is passed at the top of the application, and in every component of our application we can use use context to get the root store. What are my conclusions? The first one, that the local state looks different than the others. The second one, that lifted state looks very similar to global. Both are provided by context and both may have children stores. And the last one, that all children stores must be initialized at once in global state, so it may cause the performance issue when our application grows. So what are my ideas how to solve those issues? The first one is that we should write and provide all the store types in the same way. We should also introduce clear naming convention for easier reading the code and writing. The global state is just a lifted state, but provided only on the app component level. We should also allow stores to inject each other to prevent from the data redundancy, which is obvious. And we should initialize the stores only when needed. My dream is to scale this application easily in the future, so I need that the code for the stores should be tree-shakeable. So first thing is a naming convention. I would suggest to add suffixes to the name of the stores and files, and which tells you what is inside before you go deeper. So the data store is a store which keeps server or local storage states inside. For the server data, it should store just the raw data that came from the backend without any other transformation. The view store is a store which contains the client state, for example, modal opened or selected IDs, and it also should inject many other data stores or view stores. So the view store is some kind of facade and derived state for the component that we are working on. So for example, we have users list component, which should have dedicated users list view store, and this view store should gather all the data that this component requires. Location store suffix would be useful for states synchronized with the location state. To achieve dependency injection and to glue every stores and React components together, let's borrow two concepts from Angular. The first one is the dependency injection, which could be applied to both MobX stores and React components. The second one is to break the application into smaller functional modules. I will explain later what is the module. And to implement such ideas, I will use, and I recommend to use, react-ioc library. Alright, so what is a module? Module is a larger functional fragment of the application. You can recognize it by the place where the routes or modals are configured. And the module provides all shared down services like stores or HTTP services and so on. And module can contain another modules, so can be nested or hierarchical structured. And also the code of whole module should be tree-shakeable. I will show you later how to do that. The react-ioc library is a helper which implements hierarchical dependency injection, and it can inject dependencies using React hooks and automatically calls the dispose method on created class instances when React unmodes the provider component. and supports lazy service registrations with code splitting. It's very difficult for me to explain you all those items, how it works, and let me bring some code examples, and later I will show you in live coding how it works. So the first example is of a provider and use instance functions from react-ioc. We have users list component, which is defined here on the down, and we use the provider helper from react-ioc to configure what kind of, let's say, services, in our case the store, will be accessible by another API, by use instance hook, to be consumable like the React context. So when we provide users list view store here, this is a reference to the MobX class store, then inside the component and all its children components, we can just write use instance and put also reference to this class, and we have injected ready to use store. Of course, the component should be wrapped by observer to be able to track changes. The next helper is an inject from react-ioc library, which allows you to inject other stores inside one store. So when we have the class users list view store, which is an MobX store, we may also create the class property users data store, where we want to inject another store. We need to pass this reference. This is requirement of this library. So inside code of this store, we can access users data store by this dot users data store. And when we want the MobX store to be unit testable, then we need to bring in the constructor all the dependencies. So we should change our code that we just declare the class property with its type, and later we can assign either passed by the constructor argument users data store. If it's not passed, then we will use dependency injection toolkit to inject it automatically. All right, it's time for the demo. In the demo part, I'm going to implement a very basic application. Let me show you. The application will contain just the users section, and I will implement much basic view done here with a list of the users and the modal for adding a new user. All right, let me start this application from scratch. All right, let's go to the top of the application and let me start creating the routing first. So I need browser root from React router DOM component. Then inside the route I need the routes, also from React router DOM, and the first route will be for paths the users. Okay, let me import it, and the users will be implemented by component named users module. All right, let me create functional component, and users modules is again routing component, which defines one route to the users list component. Users list. Let me create users list. Create function component, and users list will be div where we have basic list with first name and last name. All right, let me save it. Okay, we have no routes meshed by location at the top. Let me fix that. So the top route will be a link. Go to users. The link from the React router DOM and to users. Okay, so we have this link. When I click, I'm on the users path and I see this component to be rendered. On the users list, I want a button which adds a new user. Add new user. And when I click it, I want to open a modal component which is not implemented here. So let me create a modal component inside the users module. I will wrap routes into React fragment and I will create user modal component here. All right, let me split components with separator, and the user model will use dialog component from material UI, and here we have the form for adding new user. All right, and this dialog requires property open required, so I need to put some value there. Yeah, I have onClick not provided. Yes, so currently we are on the user's path and the modal dialog is opened, and now I want to steer adding and so the opening this modal by clicking add user in users list. So how can I do that? The first idea is that in the users module I could handle on add new user event from users list, and I could get this event and pass to user model as opened and this value, but this is a props drilling that we want to avoid. So I will provide the model store. So let me provide MobX store user model view store, and in the constructor I will call make auto observable from MobX. This store will have opened boolean value as a state and two action. One is the open, which changes opened to the true, and close action, which changes opened state to the false. And now I will use react-ioc library to provide this store in the components tree, and I will provide it where? On the user's module level. So to provide any service by react-ioc library, we need to use provider higher order component, and in the second part I need to put the React component, and on the first one callback I will put user modal view store. So this is a reference to the class, to the constructor, in fact in the JavaScript, and I will import this provider from react-ioc. So now I can inject this store in either users list or user modal component. So let me inject first in the user model. I will use instance helper from react-ioc, and I will need to just pass this store, and instead of open true value I will replace it with store.opened, and now I will save it. Alright, the dialog gone because opened state is false by default. And now let me go to the users list. I'm going to inject this store, modal store also. It's user modal view store, and on the button click I will call modal store open action. I could use a reference to the method because I used auto-bind feature from make auto observable, so this will be handled correctly. And when I save it, when I click, nothing happened. If nothing happened when you are using MobX, then it means that you forgot to use observer wrapper. So in the place where we are using MobX reactions, we should wrap component with observer function from MobX React Lite. When I save it and I click, yes, now it works. So when I click here, it doesn't work anymore to close it. So I will also pass to dialog on close event store close. And now when I click this area, I should close it. All right, so it works. It was very easy to provide and inject some store inside the components. In the users module component, it's enough to pass this reference in provider function, and in the consumers components it's enough to use instance hook and to pass the class reference. And the modal store, of course, handles also TypeScript typing. So if we use something badly, then we have an error. All right, so now we have one class injected to the two components, and they both share this state. Let me change up to app module, because as I told you before, the module is a wider functional fragment of the application which could be nested, and app is also some kind of module, top level module because it contains nested modules like users module here. All right, now it's time to fetch data for the users, because currently we have hard-coded values in users list. And to do that, we need to create two classes. One is the class users HTTP service, which has get users promise, which will returns as a user JTO array. I have prepared some Typescript types for the data that is coming from the server, and I have also ready server deployed, which is able to respond with the users data. And this get users method will use fetch API users, and then we want the JSON response from there, and we will provide it on the app module level. So I will use provider again, and in the second braces I need to put the component. Let me format it differently. All right, script. All right, so I have ready to use users HTTP service, and it's time to write the data store. So now I need to consume this remote API. So I will create the users data store, and this data store will have a response property which will be user JTO array. By default it's empty. In the constructor I'm going to call the read action, and read action is an async method which will retrieve the response from injected service. So now I will use inject user HTTP service, inject helper from react-ioc library. Maybe I will rename it the users HTTP service, and inside the read action I can use this service to get users. Of course this is a asynchronous operation, and now when we have asynchronous operation, we know it from the last episode, we need to wrap it with running action to mutate our state. All right, it's very basic. Let me also print when this store is instantiated. It will be very useful for debugging, and also the user's HTTP service. And I will provide this user's data store at the top level, because every data store in the application scope is a singleton related to the backend. So it's not smart to have multiple instances of data stores for the same entity from the backend. So you should always put data stores as a singletons in the application to avoid data redundancy. Alright, but I'm a fan of a lot of stores, so I will provide next store. This one will be consumed directly by our users list. So now we have users list view store, which will inject a users data store by injecting this users data store, and users list store will have a computed function or getter users, and these users will be users data store response and map as a object with ID from the backend and full name, which is user first name space user last name. Alright, and this users list view store I'm going to provide as a local store in the users list. So I will use provider here, and in the next brackets I will wrap the component, and I forgot observer wrapper also. So now we can inject into users list list view store, and I can modify this fragment by store users map, and we will return the list element with unique user key and user full name, and bam, we have. In the network, I can see that the backend responded with 2 items, John Doe and Mary Smith, and I can see them in my list. In the console log, I see that users HTTP service and data store have been created. I will also put the console log to the users list view store, and it looks I forgot to create make auto observable. All right, so I have 1, 2, 3, 4 stores and services provided on the different levels of this application, and when I'm on the user's screen, we see that they were created and everything is connected and it's working fine. When I go home and I refresh the page, now it's the most interesting part of this demo. None of those stores have been created, but I provided in the app module level users HTTP service and users data store, and none of them is listed here. They were not created until first component needs them. What does mean that components needs it? So it's basically triggered by calling use instance helper, or if we have injected dependencies, then if needed service requires another service by injecting, also this service will be created on demand, on the fly. So when I go to the users, then all of them have been created and the network has been triggered. All right, so this is very performance friendly solution. it's a little bit better than pure React Context API, because React Context API requires that you provide ready value that will be passed to the children components. react-ioc allows you to just declare what will be instantiated later on demand, not ready value. So this is the power of this very small library called react-ioc. And let me show you something else. We are on the users list. When I go back, it uses history API of the browser, so the page is not reloaded fully. So when I go back, I'm on the main page. When I go forward, it looks like API is not triggered again. Why? Because this user's data store, once created, has been reused later in the application. It would be destroyed only when the app module would be unmounted from React component tree. So until app module is mounted in the application, those provided services lives with them. So this is why I told you to put data stores at the top level of the application as singletons to survive every user interaction in the application and to be cached in the most top level part of the application. Alright, so I'm fine with that, but now it's time to split the code. So currently I have everything in one file, so let me move users module to another file. So when we reload the page, we have currently one big bundle with everything. I want the user's code to be loaded only when user goes from the main page to the users. Alright, so let me prepare another file. It will be users module TSX, and from here I will move everything what have users in the name. I will leave just app module to the users module file. Alright, let me go back to the app. Okay, now the app module is clean. It imports everything from the file that I created previously, and the users module file has everything inside. Alright, and what happened with our bundle? Nothing. The bundle is still big. I can search here, for example, users HTTP service. Okay, it's there, and maybe I will search by class. Alright, it's in this bundle. So if you want to split bundles to smaller chunks, you need to use React lazy helper. So let me import users module differently. Alright, so I will use users module lazy. Lazy is from the React, and here I will call something like that, and I will remove the old import, and it looks like I should also remove HTTP service and data store service from here. Alright, I will move the providing point to the users module for a while. All right, and users modules can't be exported as a named module. It must be exported as a default to have enabled this feature by React Lazy and Webpack module splitter. And now when I save it, okay, let me see how it works. I'm going to users. Something is not working. Yes, I forgot to use suspense from React. Oh, mess. Let me move routes inside, import from React, and it requires me to provide the fallback. Yes, now it works. We have lazy loaded users module. Now let me check the bundles. In the first big bundle, when I want to search class users, it doesn't find anything. And we have second chunk. When I find class users list view store, yes, we have all user-based code here. But I changed the place of providing the user's data store and user HTTP service. Those services now are provided here in the users module. And what happened? When I go back, and now we have shown that previously those three items have been created. Now when I go forward, again, those items has been created from scratch. So user's data store and user's HTTP service didn't survive this user interaction. So they were recreated. And also the HTTP network fetched the users again. So that's because the data store have been recreated when users module were mounted again. To fix this situation, I need to register those services on the app level, but I can't import them here because they will be compiled in the main bundle, and I want to avoid it. So the react-ioc library has very smart API prepared for lazy loading and tree-shakeable code. So I can call app module from here, and react-ioc adds register function to this component, so I can register my user's HTTP service and data store like I'm using the provider. So it's similar API. Let me format this that way. And now I'm on the user's path. The network has been called. When I go back and forward, now the user's data store is not recreated from the scratch, so it survived my interaction because now it's registered on the app module level, not on users module, and I didn't have to import users HTTP service and data store on app module file because I was using this cyclic reference to app module here. And this is why I recommend react-ioc and MobX stores to write scalable applications because of that feature. I can control the bundle size for the application by nearly seamlessly. This code is not very complicated, it's very easy, and I can move the point where I provide the store, and then I'm changing is it a local state, lifter, or global. And if it's a global, I can also control in which bundle it will be compiled, this code, because I'm able to register my services on the upper level like here, and it's still very easy. Let me summarize what I already did. I prepared an app module component and users module component with users list and user model, and on app module, users module, and users list, I used provider function from react-ioc, which created the injectors. Injector is a place where provided services are instantiated, and their dependencies are also resolved and instantiated when needed. In app module level, I created users HTTP service and users data store, and users data store requires to inject users HTTP service. So the injector container was able to find this service inside itself, so it able to pass to this data store. On the users module, I have provided the user model view store, which would be consumable by users list and user model, and this store had no dependencies. And on the users list, I provided the users list view store, which wanted to inject users data store. So the injector, using the React context API under the hood, tries to find the upper injector. So if list view store requires users data store dependency, then this injector first tries to find itself if it's already provided here. If not, it goes upper to the parent injector and asks him, hey, maybe you have user data store. And this injector again tries to locate it inside. If it can find, then tries to ask upper until this dependency will be found. So in that case, users list view store can inject some service which is shared on the app module level. In the users list component, I was using useInstance hook to get user model view store. So it was first tried to retrieve from its injector, but it wasn't there. So again, using this inheritance path, this user model view store were injected from this level. And users list view store could be retrieved directly from its injector. In the user model component, I was using useInstance hook to inject user model view store. And in this situation, the user model had no own injector. So useInstance is also using under the hood React context API. So he goes up and tries to find in the parent's path where is the first injector connected with the component. So the user model view store in this situation is injected directly from this injector. To summarize everything, My recommendation? First of all, break the application into functional modules. In that case, you can nest your application to smaller parts. You may also scale horizontally and vertically in the components tree your application, and location paths and routings are your tool to handle, for example, splitting bundles. React-ioc is some kind of React context on steroids, as I shown you, that it's super easy to use and super powerful. The next thing is to naming convention. If you provide clear naming convention, not only the same like mine, sometimes I saw that people name those stores like UI store and domain store. So please take any naming convention in your team that is clear for you. And lazy loading and tree shaking is a performance friendly feature that I also recommend. And having a lot of small stores is fine, because when you apply my recommendations, you will find out very soon that you have a lot of stores, a lot of data stores, view stores, which are connected between them, and it may scare you, but please don't worry, it's fine, because it represents how complex is your application. In the next episode, I will try to present more handful examples. So I will show you reusable view stores with injection tokens. For example, how to reuse modals, selections, and async loading stores. I will present you how to pass React props to view store, how to make advanced data stores with RxJS, and how to integrate a MobX store with GraphQL. Thank you all for kind comments, and see you on the next episode. Bye.